We're picking up on page 170 and we're going to start building this web-based calculator. Before you begin your work, you should go to your folder, create a version of the project that you've been working on. So I'm going to go in and find that. And I'm going to pause the video for a moment while I do a little file management. All right, I'm going to go ahead and create a copy of my work, paste it back into the folder, rename that. I don't think it's completely done, that's why I'm calling it that, just so I don't think in the future that it is. All right, given that fact, I'm going to go into Visual Studio 2012. I did it again. 2015. You guys got to catch me on this, because this morning I'm working in 2012 and now I'm working on 2015. We are. All right. We're going to go up here to the File menu. We're going to choose Open Website. You're going to find your site and open it. And I'm going to go ahead and drag the book off to my other screen here. I'm also going to go ahead and close up all the tabs that I have open just to kind of get them out of the way. I want us to begin by creating a new web form, and we're going to do this inside Demos folder. So I'm going to do a right-click, Add, Web Form. And then we're going to call this Calculator Demo. And you can see it created the page and the code behind file. They want us to take the page over to Design View, click inside the box, and then we're going to go up to the Table menu, choose Insert Table. And they would like us to create 3 rows and 3 columns. So I'm going to change these numbers here to 3 and 3. All right, with the next instruction, what they want us to do is they want us to take all 3 of the cells in the top row here and merge them. And that's kind of what I was doing in the last video with Excel, where it was naming the array. So it's really kind of the same concept. And the way that I'm going to do this is I'm already in the first box. I'm holding down my Shift key, and I'm right arrowing. And now I have all 3 selected. Now, once I have them selected, I can opt to right-click, and then I think it's under Modify, Modify, and then Merge Cells. So then what happens is those 3, the top row, became one large cell. Interestingly, if you go to the source code and see what it did, and if you know your table code, it just took that top row where that TD is and did a column span of 3, and now that one TD covers 3 spots. Now that's some basic HTML stuff that you guys should already know, but I'm just showing you that how easy it is inside this product to do stuff like that. So if you don't remember the code for merging table cells, either vertically or horizontally, it's kind of a quick little tool for doing it. All right. The next thing that they have here in the instructions, and I'm going to pull them back over, is they want us to go through and basically create what we see on the screen here. we are going to add a number of different things, and they want us to drop it into the table basically in the same spots we see here. So I'm kind of zooming in. And if you look really closely at this image, where the result label is, that's in that top area that we merged. Then we have, it looks like a text box, a little drop down, a text box, and a button. So the second row's got 3 items, first row's got 1, the third row's got 1 in the center cell or column. They give us a little list here of what to add and what properties to set. So I'm going to go through and go through this table one at a time. I'm going to talk through it, but you guys feel free to race ahead if that's appropriate for you. All right, so the first thing they want is they'd like a label. They want that in the top box. And it says clear its text property, which is down here. And then just press delete. They just want us to clear it. And then they also, I think, want us to set its ID to result label. There cannot be any spaces here, folks. And name it just like the book does, so that way if you copy any code, it'll work. That's pretty important. All right, then we need a text box. That's going to go here. The ID for that should be value box 1. Since we're already doing text boxes, let's drag another one over, but that's not going in the middle one. It's going all the way to the far right. That one's going to be called value box 2. In the center, they want us to grab a drop-down list. So that's going to go in this little box right here. So we got a drop-down list, dropped into the center box in the second row. And it says add 4 list items for the following arithmetic operators. And you can use a little smart task panel. So I'm just going to click on edit items. And then I'm going to add. And the text is going to be a plus sign for the first one. Minus sign. An asterisk for multiplication. And a / for division. And then say OK. We should also give this an ID. They want us to use the name operator list. Finally, we need to add a button. That's going to go bottom row, center box. They want us to set the text property to be calculate. And they want the ID to be calculate button. Now, for those of you, if you're not seeing like that text field and the ID in the same spots, it could be because you're in a different mode. By default, Visual Studio is in this categorized mode, and I often like to go to the alphabetical because for me, I can find stuff faster when it's being called out by name. Just in case you're not finding it in the same spot where I'm at. All right, so with any luck, if you click off of all these boxes, your design view should look something like this now, or hopefully exactly like this. And then we're going to add some code. So in step 5, we're going to go ahead and we're going to double click this calculate button. And that takes us over to the code page and automatically creates the default action for whatever object we double clicked. In this case, the click of the button. That's the default action for it. And I'm going to copy the code in the C# section here. So right here, I'm going to grab all that code. Acrobat's being finicky. There we go. So I'm doing a Control-C to copy. And just remember, when you're copying and pasting code out of the book, it expects that you used all those exact names when you were naming all your objects. I do have a little bit more code to copy in. Don't try to copy across pages, because what will happen is it'll bring all this extra stuff over with it. And then I got to remember to be right inside the right spot here. So we ended with a semicolon. So we're going to paste right there. I am going to do a save on both pages. And then I'm going to go back to the code. Oh, and I see what happened. Maybe you guys did exactly this. I wasn't being smart here, because when I double-clicked that button, it automatically created this stuff. And here I am pasting it back in. So guess what I'm going to do? I don't need 2 of those. I just need 1. And that also means that I'm going to have an extra curly bracket down here at the end. So I'm coming way to the bottom, and I'm getting rid of it. So your completed code, I mean, if you want to see the whole file at once, that's it right there. I know it's hard to see. But for the section that we're working with, is we were just working inside the calculate button, click, and then basically we're adding this code to it. Now if you examine the code real quick and see what it's doing, it's saying that anytime we click that button, we're going to run this code. First thing that code is going to do is it's going to check to see if whatever is in value box 1, its text, its length is greater than 0. So in other words, you have to have something in there, right? Can't do math with nothing. And the same thing with the other box. So it's checking before we even start, do you got numbers in there? Right? No numbers, no math. So if it didn't have numbers, it would just jump down here to the else, because it would be false, and it would just give you nothing. Can't do math with nothing. So if either one of those is empty, that would be the case, because in order for this to be true, both number boxes, or text boxes, excuse me, have to have a value inside in order for this code to run. For this code to run with numbers inside, it will come in, and we set up 3 variables here. All of them are doubles. We're taking result, which is going to hold the answer to the math, and we're setting it to 0, so it starts with something. Then value 1 is going to grab whatever is in value box 1, its text, which is text, and you should know that. If a person types in a number, it's still text. We have to take that text, convert it to a double, to a numeric format, and then put it inside the variable. So we're doing that with each one of the text boxes, and that's kind of a standard procedure. People in Java class, think about when we're grabbing stuff from the keyboard and we do like next int or next double. It's really the same thing. We're doing exactly the same procedure. Once we have the 2 values, Then we check to see the value of the drop-down. So we're looking at the operator list, that's the drop-down list that we created, and whatever the selected value for it is. And then it just says, did you choose a plus? Nope. Did you choose a minus? Yep. First one minus the second one, put that answer in result, and stop. Get out. Break. If it happens to not find any of these symbols, which shouldn't be the case, right, it just won't do a thing. But they only have 4 choices. We hard-coded them, right? It's gonna be one of those by default. Probably the one at the top. When everything is done after that switch statement, then we're going to take that result. Notice here, the result's going to be a number. But I can't display the number in a text box or in a label. It has to be converted to a string, or basically a series of characters first, and then we can display it in the text box. So that's all the code is doing. Really very, very primitive little calculator, but it will work. All right, do a Control S to save. All right, so at this point, I believe what they want us to do is probably launch the code and see if it works. So we're on step 6, page 172. So it says go ahead, save changes. So I'm going to hit my little save all icon here. And then I'm going to go ahead and run it. Now they suggest Control F5, which is equivalent, of course, to hitting the second option. It means we're not running debugging. Code should all be fine because we're copy pasting it. And click OK. Of course, it comes up on my second screen here, but I'm going to pull it over. And I'm very widescreen, so I'm going to narrow it up so it doesn't look ridiculous. So you see our text boxes, our drop down. So what we're going to do is we're going to type in some numbers. It's plus, calculate, and the answer is 4. All right. Try a different math operation, subtract, multiply, divide. All the answers are correct, thankfully. The other thing that we should try is leaving one of these blank, in which case it should do nothing. Right? That's what we programmed it to do. And if both of them are blank, it should also do nothing. Why do you have to spoil our fun?
I know what happened.
Yeah, I know. Yeah, so we're divide by 0 can be a bad thing. Right. What does it do? It gives you infinity. How do you like that?
You got the infinity symbol spelled out.
Did it really?
Yeah.
Oh, that's interesting. My code must be special. Yeah, maybe it is the browser. It could be the browser. All right, well that's the application running, so we'll consider that little exercise a success. And let's move on. All right, they go through the explanation here. Next programming construct we're going to talk about is a concept called loops, another thing that's common to just about every type of language. Loops have a lot of different forms. A real common looping type is a for loop. For loop is one where you set your loop control variable or sentinel value, depending on the approach that you were taught. People use different names to describe these things, but it's really the thing that kind of controls the execution of the loop. And if you use like a while statement, typically that would be placed outside the loop, but we're doing a for loop, so it gets to be declared and set right inside the for loop declaration. In the center section is where we have the criteria to see if the loop is actually going to run. And then finally, we are setting a value for changing the value of the loop control variable or the sentinel value so that we can eventually jump out of the loop. So in this case, it's set to increment. And how this reads, it says loop count equals 1. So we preset it to 1. then we check to see, is loop count less than or equal to 10? Well, it better be because we just set it, right? Otherwise the thing won't run. It is, so it's going to keep going through, and every time it goes through this loop, it's going to increment that counter by 1. So what's going to happen is the first time through it's 1, so it runs. Second time through it's 2, so it runs. Every time it runs, what is it doing? It's taking the loop count, so whatever the number is at the moment, the first time it'll be 1, converts it to a string, and adds an HTML line break at the end, and puts that into the text box. So it's going to print 1, 2, 3, 4, 5, 6, 7, all the way up to 10, and then when it hits 10, it will still print 10, but after the execution of the 10th loop, the counter will trigger, set it to 11, loop count will no longer be less than or equal to 10, and it will stop. So this loop would output to a label 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, each on their own line. Okay, so that's what that loop does. And that's kind of a little bit of review of how loops work. And I'm not going to dig real deep on this. There's also loop structures called for each. And for each, instead of having a little counter or a loop control variable that we're using to kind of monitor things and keep it going or see if it's going to go or not, for each very simply attaches itself to usually like a list or an array, a structure that has multiple values, and just simply steps through each one automatically. So it just hits each one, and then when it's done, it's done. I don't have to set any values or increment or decrement anything. So that's very commonly used when we're working with like data that's like in a text file or a database or an array or a collection or an array list or something like that. Okay, so that's a for each. Chances are when you first learned what a loop is, you probably started with a while loop. That's one of the ones you learned first. And notice that a while loop is not too much different. Probably the most notable difference, and I'm looking for a better example here. I like this example better. That loop control variable is actually set preceding the beginning of the loop. So I have to declare the variable outside the loop and give it a value, and then I can still check to see if that value is going to hit in order to trigger the loop. But you're in control of that outside of the loop declaration itself. It actually sits separately. And then also notice that the increment for the loop is just a statement inside the loop itself. So if I forget to do that, that loop is going to just keep running and running and running because whatever triggered it to run is not changing. So that's on you to know that you need to change it. Okay, folks, I say this in just about every programming class that I have. Pretty much, depending on the kind of problem you're trying to solve, you should be able to accomplish any repetitive task using pretty much any type of loop. As long as your logic is sound, you should be able to do the same thing with a while loop that you would do with a for loop. Generally speaking, though, what happens is certain types of loops will lend themselves better to certain types of problems. So you'll find people that know that a loop needs to execute a finite number of times will typically opt for a for loop because the syntax is cleaner in the heading. Somebody that wants to check to see if a password is valid typically will work with a while loop because that makes more sense. That's an example of that. All right, loops do have some pitfalls, of course. It is possible to throw in little things like break statements like we saw in switches where you can pop yourself out given particular conditions. You also have little complications where sometimes you get caught into infinite loops, which we talked about briefly. These are concepts you really should have learned in your intro to programming class or other programming classes. Not something I'm going to do here in depth. Next topic that we have is breaking things into what we call functions and subroutines. And notice how this book prefaces that with methods. Because when we are working in C#, we call those things methods. When you learned Visual Basic, they were called subroutines and functions. And a subroutine is different than a function. In essence, a function returns a value and subroutines do not in VB. In C#, it doesn't care so much. It just calls them all methods. And you'll see that the declarations are real similar to what we see in Java, where we're doing publics and privates, and we will state the return type right in the declaration. Very, very similar. The whole point of having a method or a function is basically to allow for you to create a block of code that you can call upon by name. The block of code can be reused multiple times by multiple parts of your program. And it really creates a nice, clever way, like if you come up with a piece of logic that can be useful in a lot of programs, that code reuse is huge. But it also allows you to take like the main program body, like where most of the tasks are being executed, and have a simple list of things that are happening, and each one of those things is branching out, going to a different set of code, and then coming back. The difference, of course, as I mentioned before, with if you're familiar with VB, is then VB, when something is returning something, you list the data type it's returning, and you give it the name function. Otherwise, it's just called the sub. In C#, they're basically the same thing. You see that? The difference is, in that second position, what you are returning. Are you returning something? And if you are returning something, what's the data type? If you see the word void, just like in Java, you guys, that means you're not returning anything. And in C#, that's called method. To make a method run, you very simply put it together, give it a name, and I'm looking for the example here. All right, here's an example where they put together a little method. It's not going to return a value, but it does have a name called byRefDemo, and then it indicates also that we are returning that value by this little declaration here. It indicates a value coming in, and that value is going to change on its way back out. But in order to call any method in C#, you just use the name of the method followed by parentheses. Some methods will require that data be sent to them, and some will not. Whatever the case may be, you need to remember that the data that you're sending in, the data types must match. So if the declaration says it needs to be an integer, you better send it an integer. If you're sending an integer and then a string, you better send them in that order, in the order that it's expecting, just like you would in Java, right? And it's true just about every language. All right, let's talk briefly about the app code folder. And this is what I was mentioning kind of early on, right at the beginning, is how, depending on the project template type that you choose when you begin, an app code folder might be automatically generated for you. Doesn't mean that you cannot manually add it. You absolutely can, but it does have a special meaning inside these projects, basically that you're putting in code that's going to be used pretty much anywhere throughout the program. Once again, the code file is not directly attached to the web page. It's part of the project. So that is accessible by all parts of the project. Any of the pages can use that code. All right, let's move on to the next little exercise here and see if we can get through this one. All right, so now we're going to switch things up with our calculator. Once again, I'm going to pull this off screen and read from there. First thing they want us to do is they want us to go ahead and add an app code folder. Now this is a little different because you don't just want to add any old folder. This is, a folder that has special meaning. and therefore basically has to be registered within the application. The application needs to understand that this folder is there and it's going to have that special meaning. So instead of just doing add folder, we are going to do add ASP.NET folder. So you see that option there? And notice how intelligent it is. You know, it realizes we're at the root and we're right-clicking. And the kind of folder that we want is app code. But, you know, while you're in this interface, just take a look real quick and see that there's other types of ASP.NET folders with special meaning as well that you could add to your project. Right now we're starting with one of the basics, which is app code. Then they want us to right-click this folder and add a new item. We want to add a class. I'm just going to choose it from the quick list here. There's no reason not to. And basically what this is doing is I'm just creating a straight up C# file. It's not attached to an ASPX page. So not a page with a code file attached, just straight up code. And let's see what they want us to call this. They want us to call this calculator. And then go ahead and click OK. Then you can see the file right away. Notice it's in the app code folder and it's not attached to a file. Also take note, it's got a different little icon there because it's just a straight up C# file. Program code only. In step 5, they have a bunch of code that they want you to paste in. All right, it says right after the line of code it defines a calculator class, add the following 4 methods. So I'm going to do that. I'm going to grab, and if it's helpful for you, you can watch me copy paste. It's not that exciting, but here you go. So you see I'm not grabbing the public class declaration here. I'm just grabbing the stuff inside that's bold. So copy. And actually I don't even want it in the constructor function. I want it here. And I'll copy the rest. Paste it below. And the truth is we're not even going to need this. So I'm just going to delete it. And that's the one that was in there before we started. So your completed code should look like this. And you can see if you copy pasted like I did, you guys see the little red underlines right here? Do you guys know what happened? Yeah. Yeah, what it does is the copy paste, you know, printers use different characters in their books than code uses to code. And basically that minus sign turned to a dash, which is technically a different character. So what I'm going to do is I'm going to delete it. I'm going to type in a minus sign. You see how it fixed? Okay. If you're just typing, if you're following the book and typing, it's not going to be a big issue. If you're copying and pasting like I am, that can sometimes be a significant issue, so you got to be careful of that. And if you're new to it, you might not understand why it's happening or because you haven't encountered it before. But I'm trying to give you that little heads up, save you a little bit of heartache in the process, I hope. Okay, on to step 6. So in step 6, we're going to move over to this next file, the file that we were working on previously that ran the calculator, and we're going to pull up the code behind page that goes with it. So find your calculator demo C# file, and then inside each one of these statements we're going to do a little code alteration. So you can see what the intended result is. And notice what we're doing here is basically we're converting from doing straight math to calling the method that's in the other file. And it is throwing an error. We'll fix that. Don't worry about that. All right. It says first you need to add a line of code, and this is the part that you might miss. So right at the top of that switch statement, right here, and we're creating an instance now inside this file of this calculator class. So we came up here and we created this calculator class that has the name of calculator, and then inside of it, it has methods that do the math for us. Each one of those methods is going to accept two numbers, and then it takes those numbers, does the math, and returns the value. In order for us to be able to leverage that capability in the calculator demo C# file, we have to basically create a version of that. What we call this is instantiating an object based on the class. So we have the class file. We're creating a version of it right here for our usage so that every time I say my calculator, it is pulling in all the capabilities of calculator from here. In essence, what we're really doing is we're creating our own data type. So calculator is something that we defined. It's got capabilities by virtue of the methods inside of it. We're creating a new one. So now it exists here. So every time I say my calculator, followed by a period, and then I call one of the methods within it, we're going to take the numbers that are coming in, we're going to send them off to this method to do the math, and it's going to return the result back here. Now, this is not really necessary. I mean, in terms of the functionality of the application, it's already doing the math, right? The point here is to show you how methods and classes work. So I have a class file I created that separately. I created an instance of that inside this page code file, and then I can call it by name and then call the methods that are attached to it and do the work I want. In this case, we're doing very simple math, but it could be that it was a very complicated series of steps, and that would all happen with one simple little command. So if you're following along with the rest of the examples in the book here, clearly we're out of time here in class, so I'm not going to be able to finish this one. You would copy and paste the rest of that code in and get it to work. All right, folks, that wraps our session tonight. If you need more video files to help you step through the rest of the chapter, look at the archive videos because I do finish it off there. Even though it's probably using Visual Studio 2012, the steps are all identical. Thank you.
The sentence said the